This is the November 2022 Mathematics Paper 2 for the CAPS Nsc, grade 12. We're doing question 3.3 in this video. So question 3.3 says, calculate the size of angle DCA. Angle DCA. So I filled in some of the information from the previous question 3.1 and 3.2. So all the pink here written is all the information we had. This is angle DCA. And I just want to talk about it a little bit, sort of how I'm going to approach this question. So first thing I want you to notice is that there are these parallel lines that was given. So DC is parallel to AB. And if you take a look, there's a little Z in there. So if we look at our DCA, it's going to be equal to our CAB because of alternate angles of parallel lines. So that's the first thing I want you to notice. So the proof that needs to be proved after that simply becomes what is this angle? So we actually asking what is CAB? What is CAB? Okay, so that's a little bit easier because we already have quite a lot of other information. So then our plan of attack changes because we can, if we have this angle, which is simply the angle of inclination, that's the positive angle of AC, the line AC, which we have the formula for. It was given in the formulas. So if we take this angle of inclination, which we know we can get with tan theta equals to m being the gradient of our line, then the final step, we can just look into this triangle FAR, F-A-R. And if we take the internal angles of a triangle, take 180 minus the green angle minus 71.565, which was there from a previous question, then we can have our answer of FAR, angle FAR. And after that, once we've got angle FAR, then we actually have immediately angle DCA because they're equal to each other due to the parallel lines. Okay, let's get that written up. Question 3.3.1. First part of our proof was that angle DCA is equal to angle CAB. And the reason for this is alternate angles, because the line CD is parallel to line AB. Let's just check if those are correct. So we have CDAB correct. Okay. So that's the first part of our proof. So now it becomes, what is CAB? Well, the first thing that we noticed on was the green angle we could get with the AFR, the green angle AFR. In order to get angle AFR, we can use the angle of inclination. And we know that if this is theta, then tan theta is equal to the m, which is the gradient of our line. Which line are we using? Well, we're using AC. So MAC is equal to our tan theta in order to find theta. So we can say that theta is equal, take tan to the other side, is tan to the -1, 10 to the minus 1 of m of the line AC, of the gradient of the line AC. All right. So we need to just quickly grab that formula. AC is 5x minus 6y equals to 8. So currently that's not in standard form. So first thing to do is change it to standard form. We can start by minusing 5 on both sides. 5x, minusing 5x on both sides. We want y to be the subject, so we divide all the terms by negative 6. So these ones cancel out. 8 over negative 6 is negative 4 over 3. And 5 over 6, negative times a negative makes a positive. So it's a positive 5 over 6x. Just quickly rearrange this a little bit. 5 over 6x. Okay, so this is AC in standard form. And now that it's in standard form, we know that our M position, so we know that M is actually going to be equal to 5 over 6. Now we can come back to where we were. So here we had MAC, so we need theta equals to tan minus 1 of 5 over 6. Okay. Put that in the calculator. 10 to the minus 1 of 5 over 6 comes to 39.80557,109, which we can round to 2 decimal places as 39.81. Okay, so which angle was that? 39.81 was our green angle over here. Was our green angle. So we can now fill in that this is 39.81. Okay, we've got everything we need. So the final step in order to get angle FAR is to take the interior angles of a triangle. So it's 180 minus 39.81 minus the third angle that we already had from a previous question, which was 71.565. Once again, quick calculator work. 180 minus 39.81 minus 71.565. Okay. From this, I get 68.625. 68.625. And final conclusion, remember that the angle FAR is equal to the angle DCA. The final conclusion, therefore, FAR is equal to DCA. Therefore, DCA is equal to 68.625. Round to 2 decimal points. The mark scheme I see has this as 68.62. I get 68.63. So I get 68.63, rounding it up because the 5 goes up. But maybe because of some decimal points or something, in order to stay like the mark scheme, I would just put it as 68.62 to continue with this question. So we're going to, even though this is what I got, so I'm going to write 68.62 so that no further questions have any problems, to keep accuracy with the mark scheme. Okay, this is correct. I'm sure that if I had done the decimal points differently, this one would have also been correct. Right, let's see. So now we have 68.62, and we can fill in this one as well. Number 3.3.2 asks for the area of POSC. So it's POSC. Okay. I'll talk a little bit about this first, and then we can put down the proof. So POSC, for me, I immediately see it as, if you take a look at the PFC, that's the big triangle, the purple triangle there. If we take that and we minus FOS from it. So we take the area of PFC minus FOS will give us the green area that we need in the middle here. There's a few steps that we need to go through to get that. Let's take a look. So we're working with non-90 degrees triangles. Non-90 degrees triangles. So we have, if this is our big triangle, PFC, and then we have a small triangle there. Well, let's see what we already have. We already have the angle 68.62, which is within the triangle. But if you take a look over here, we also have angle PFC for vert op is going to be 39.81. So those are two angles we could work with. Remember the non-90 degree triangle area of a triangle that doesn't have a 90 degrees angle is a half times A times B times sine of C, where C is the angle sandwiched between the two sides that you are using. So we're going to use this formula twice. So basically, in order to get this answer, we would need triangle PFC, the area of triangle PFC minus the area of triangle, what were those two unknowns? FOS. FOS. Okay. So this is what we are trying to get. So this area will equal the area of what the question asked for, which was POSC. Well, let's look at what we have. We don't have F yet, so we need to know what F is. In order to get distances, we also don't have P. So quite a lot of unknown points here. Not a big problem. P we can see is the x-intercept of CD. That's the x-int. We can let y equal to 0. So we can do that quite easily. F is the x-intercept of AC. So again, x-intercept, we can let y equal to 0 to find the x-intercept. So P and F we can easily gain, and we already have C, and those are the 3 points that we need. In order to use our distance formula, we can choose whichever sides. You only need to choose 2 of the sides. I'm going to do all 3 just for the proof, but you only need to choose 2 of the sides and make sure you use either the 39.81 angle or to use, oh, that's an O. That was angle 0, that's O. Oh, we need O, which is just 0, 0, just to, that we already have, that's the origin. So you either use the 68.62, 68.62 or 39.81. So we're either going to be using this angle or we're going to be using this angle. All right. So we have point C, which is -2, -3. We need F and we need P. So let's start with P. For point P, we have the CD minus 3x minus 9, we worked out in a previous question. Minus 3x minus 9. Point P is the x-intercept of CD. Therefore, we can let y equal to 0. So y will equal minus 3x minus 9. 0 equals minus 3x minus 9. Plus 9 on both sides. End up 9 equals minus 3x. And divide both sides by negative 3. Divide both sides by negative 3. Cancels out on that side. So x is equal to 9 divided by 3, which is just 3. That was negative, so it's a negative 3. Okay, so our x is negative 3. That means our point P is, x is negative 3, and our y was 0. So we have point P, negative 3, 0. Now we do the same for F. Just grab that formula. So it was 5x minus 6y equals to 8. 5x minus 6y equal to 8. We want the x-intercept. So we let y equal to 0. So 0 equals 5x minus 6y. That could be better there. And the final step is just oh, excuse me, something I did that's not correct. That was an 8. 5y. 5x equals to 8. So 8 equals 5x minus 6y. Okay. So this was not in standard form. No problem. Just wherever we see a y, we change it to a 0. So 6 times 0 is 0. We end up with 5x equals to 8. Divide both sides by 5 to get x on its own. X is the subject. Those 5's cancel out, and x equals to 8 over 5. That means our point F is 8 over 5, 0. We've solved that. We have all the points that we need. 8 over 5 and 0. Now we can continue to getting the areas that we wanted. So first, I'm going to do all 3 distance formulas. So there's 3 different distances here. Goodness me, what are these lines? Okay. 3 different distances that we can use here. So we have distance of PF, we have the distance of CF, and we have the distance of PC. And remember, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared, which is based off any 2 points, xy. Just remember, if you start on x1, you need to start on y1. And if you start on x2, you need to start on y2. So order matters because of these negatives. Order matters. All right. So we're doing the distance formula. Let's start doing our 3 distances. PF. Distance PF is minus 3 minus 8 over 5. That deals with our x's squared, plus 0 minus 0 is just 0. So 0 squared, which is still just 0. And our second distance is going to be distance CF. CF is -2 minus 8/5 squared plus -3 minus 0 squared. And PC is going to be -3 minus -2, so double negative, squared. Keep that -2 in brackets, plus we started on in -3, so we start on 0, 0, minus -3, 0 minus -3. Right, so we have our three distances. We have our distance PF is equal to 23/5. Our distance CF is equal to this 3√61/5. And our distance PC is equal to square root 10. I'll leave them in third form because the third form helps for reducing problems with decimal points. So now we need our triangle, our area of triangle PFC minus the area of the triangle FOC. O0, 0. This is S. Okay, I see that we need probably a couple more distances there as well. We need FS. And we need FO. So distance FO is from the origin. So you're just looking at the X's. And FS, we have to go grab S off the right. So I just taking a look at the original question here. And I noticed that this is actually a 90 degrees triangle. This means we could also work it out using a half times base times height. A half times base times height is easier because then we don't need to do FS. We don't need to do FS. We wouldn't have to do another distance formula. We can, when you work distance from X to X, you can just look at how far. So from 0 to point F, which we have now, is just the X distance. So it's just the X distance there. So from 0 to point F is just 8.5. 8/5, excuse me. And this is going to need the distance formula. But then if we had OS is just going to be -4/3 because you only have to look at the Y's. It goes from 0 to -4/3, so you only have to look at the Y's. So we have the distances that we require for doing the FOS. It's a little bit easier. So let's take a look at what this ends up being. It ends up being a half times A times B times sine of C, which we have to still choose which sides we're going to do, minus a half times base times perpendicular height. So our triangle PFC, for triangle PFC, I'm going to use the 39.81 as my angle. And if I use 39.81 as my angle, I have to use PF and FC. So it'll be a half times PF times FC sine of angle 39.81. Well, we have PF here, PF is 23.5. So a half times 23 over 5 divided by 5. And we have FC is CF, which is written backwards, since 3 squared root 61 over 5 and sine of 39.81. That's going to give us our area of our big triangle. And then we have a 90 degrees triangle. Remember that we wanted to minus from it to get our shape that we were aiming for. Okay. Here we have a half, our base of our 90 degrees triangle. We can do as OF. And the perpendicular height we can do as OS. We have those OS's here. This is OF. Okay. Minus a half times minus 4 over 3. But now we don't put this minus because distances are always positive. So it's just 4 over 3 in distance. And then we have 8 over 5. So the distance of OS is not going to be negative. Okay. Now we can put all of this in the calculator. How about we do it this way? Grab this. Okay, so we have 6.9 units squared minus 16 over 15 units squared, and that is going to give us the area that we were looking for. So the area is 6.9 minus 16 over 15. 6.9 minus 16 over 15 into the calculator. Equals 35 over 6, and press the SD button to get it into decimal form. And the answer is 5.83 recurring. So to 2 decimal places, this is 5.83 units squared. And this was the area of, asking for the area of POSC. POSC. That concludes question 3.3.2.